Hello students, welcome back. We are going to talk about resistors and capacitors in this video. These are two very basic and most widely used components in our circuit designs. So let us start. Resistors, they are primarily used for reducing the flow of current. They come in different shapes and sizes, and the purpose of their use is reduction of current, adjusting the signal levels, and voltage division. You can use a combination of two or three resistors to divide a given voltage into any desired voltage which is less than that. A resistor can be fixed resistor or it can be a variable resistance. When we connect resistance in series means one after another in the same loop, then they will have same current through them. The loop current in the complete loop will be same. All the resistors, they are going to face the same current, but the difference will be in terms of voltage across them, because the resistance is going to have a voltage I into R. I is same, R is different. That means the voltage across each resistance is going to be different, and the summation of all these voltages will be equal to the supply voltage or battery voltage. When you look at a circuit which is having 2, 3 or more resistances in series, you can replace all of them with a single resistance called R equivalent, and the equivalent value of the resistance is calculated by taking the summation of these resistances. Resistances can also be arranged in parallel, and when you do that, then the current will split across all the resistances. Voltage will be same across each of them. You can still replace a parallel resistor combination with one equivalent resistor, and the reciprocal of equivalent resistor is summation of reciprocal of each individual resistor. So the equivalent resistor is always going to be less than the minimum resistance present in your parallel circuit. Let us have a look at this diagram. Here we have a reservoir which is having water stored, and there are some gates. If you open one gate, the flow of water will be there. If you open more than one gates, that means you are reducing the resistance of the reservoir. More current, that means more water will start flowing. So in parallel, if you start connecting more resistors, the effective resistance keep going down. This is very similar to this reservoir analogy. If you keep opening more gates of the same size, the resistance of the dam will be less and more water or more current will flow. How do we read the resistor value? Well, when you look at the body of a resistor, there are 4, 5 or sometimes even 6 bands. In regular use, we get resistor with 4 bands. So here, the first and second one, they are for the significant figure. So have a look at them. Every color is having a digit associated. So from black, brown, red, orange, yellow, green, blue, purple, gray and white, the digits are 0 to 9. So if the first two digits are, let us say, brown and red, that means the combination of the digits will be 1 and 2, 12. The third one is for multiplier. So if the third one is orange, that means 1000. So 12 into 1000, 12,000 ohm is the value. And then comes the fourth one, which is tolerance or error. When we manufacture the resistance, exact value cannot be manufactured, and there can be an error of 5% if the ring is gold, or 10% plus minus. It can be on either side if it is silver color. So let us have a look at this example. I have a resistor whose bands are red, violet, orange and gold. So red and violet, they give me the combination of 2 and 7, and orange is 1000. That means this is my resistance value. And the fourth band is gold. That means it is 27,000 ohm with 5% tolerance. Okay, coming to the capacitors, they are as important as resistors. The main purpose is to store energy in the form of electric field. They are also two terminal passive device. Passive device means they can only consume energy, they cannot generate. Okay, now the effect of capacitor is known as capacitance. They also come in different shapes and sizes. Some of them are thin like a paper, some of them are cylindrical, they are called electrolytic capacitors, and they can be variable capacitors also. When we connect capacitors in parallel, then all of them will have same voltage across them, and the equivalent capacitance of the network can be calculated as the summation of individual capacitances. When we connect capacitors in series, they have same charge across them, and the reciprocal of equivalent capacitor is the summation of reciprocal of individual capacitances. So if you have capacitive networks with multiple capacitors, you can replace your capacitive network with an equivalent capacitor value. So now coming to the point, how do we read the capacitor values? We don't have any rings and all, we have clear written numbers on their body. If it is an electrolytic capacitor, the complete precise value will be written like 1000 millifarad. If it's a paper film capacitor which is smaller in size, then there will be a code written. So something like 101, 102, 104. So what are these codes? How to decode them? The first two digit you take it. The third one is 10 raised to power, and the value is always in picofarad. So 101 means 10 into 10 raised to power 1, that means 100 picofarad. If it is 102, that means 10 into 10 raised to power 2, that means 1000 picofarad. The same goes for some other values also, like 221, that means 22 into 10 raised to power 1, that means 220 picofarad. 471 means 47 into 10, 470 picofarad, and so on. Where do we use the capacitors? Well, the first purpose we said it is used for energy storage. A very vital use is in power factor correction. Power factor correction is done for electrical appliances. It can be used as a suppression or coupling capacitor, and it can be used for coupling or decoupling of signals. If you remember, we were discussing noise in the tone generation. So if you have two different types of signals, AC and DC, and I want to decouple the DC signal, I will use a capacitor, because capacitor will not allow the DC signal to come. Whereas if I want that certain amount of AC signal should come to my circuit, then I will use the same capacitor as a coupling capacitor. Capacitors in combination with resistors are also used to design high pass and low pass filters. So once we know these elements, we should also know how to connect them. And the easiest way to do that in a development environment is using a breadboard. We are going to study breadboards in detail in our next video.